Hello, Hornets. Today we're going to be dealing with 8.8 improper integrals. And what I'd like to just point out is that we're talking about two specific types of integrals. We're talking about an integral that starts from some base value, let's call it 1, and it's going to something that doesn't make sense, an endpoint called infinity. And this is going to work with some x to the power of p dx. Now, we call this improper because we have an infinity at an endpoint. We really can't reach infinity, and so we're looking at something that kind of doesn't make much sense to us. The other option is approaching an asymptote, such as 1 over x to the p dp. You'll notice as I approach 0, I'm approaching an asymptote. Once again, things go wrong. Things have a problem. And we can categorize them as pretty much two basic situations. The first situation says that we're looking at 1 to infinity for 1 over x to the p. And we're saying that either p is going to be greater than 1 or p is going to be between 0 and 1. And I want you to notice that it goes OP1 or OP. This is what we refer to as an OP, not to be mistaken with ln, which is the natural log, ln. This is OP, OPI, or OP1. And we're saying that we're actually saying p is between 0 and 1. Now, notice, when we're going to infinity and we have a value that is greater than 1, we can always find the integral. And we'll use our tactics and all of the methods that we've been doing in order to do this. When p is between 0 and 1, and we're moving toward infinity, we will always have a diverging situation. That means that no sum can ever be found. It'll never end. It has no sum. It grows infinitely. Now look at the second option. The integration from 0 to 1 for 1 over x to the p dx. Now things flip. So if I have a value of p that is greater than 1, and I'm going between 0 to 1, I will always have a divergent situation, and no sum can ever be found. But if I have a value between 0 and 1, and I'm going heading toward an asymptote, then I will always have a converging system. A sum can be found, and we can do it by integration. It is important to note that p equaling 1 is called the harmonic series, and the harmonic series will always diverge, i.e. grow infinitely, regardless of whether you are approaching the asymptote or whether you are approaching infinity. So let's just take a look. You see, 1 over x, the harmonic series, is what we consider an average or a neutral. Let me give you an example. Here is the harmonic series. Let me try to get rid of some of this light here and see if I can't help myself and you see it. All right, it's a little better, not by much, but we'll have to make it work. Notice that right here, as we are approaching our value of 1 to infinity, this grows infinitely. Now, if I'm going from 1 to infinity, it also grows infinitely, being two symmetric pieces. Now, what happens when I bring my power up? So let's say I'm going to increase my power. So p is going to grow. As p gets larger than 1, it forces the curve down. Might even force it over. Let's just see it going down. If it goes down, you'll notice it intersects the x-axis somewhere, and therefore we will have a sum. Now, if I happen to bring my power between 0 and 1, all that's happening is it's growing. See how it moves it up? Or more precisely, moves it over? So power less than 1 moves it this way, still stays infinite. Power greater than 1 moves the curve downward, and we have an intersection. So downward, greater than 1. Less than 1, over. Now, if that's the case, then when we look at the other situation, approaching the asymptote 0, if I have a value greater between 0 and 1, I move it over and it intersects. And because it intersects, it has a sum. But if, however, I am working with a value that is greater than 1, notice how it brings it down, and this portion is still infinite. So I'm still approaching the 0. It didn't change. This is what's happening as the power is moved around. Here we have a chart that shows what's going on. If I'm dealing with my limit approaching infinity, that's this one up here, and my p-value is greater than 1, I have a convergence. Big powers converge at infinity. If I have a small power, a fraction, between 0 and 1, I will have a divergence. The opposite effect occurs. So if I'm approaching 0, the asymptote, from the positive side, greater than 1 now diverges, and between 0 and 1, we now have a convergence. Okay? So this is what's happening, and this is part 1 of my video. Thank you very much. Please be well, stay safe, and in part 2, we will see some examples.